I should have. Yeah. Anyways, if you look at this question here, guys, thanks for the heads up, I totally forgot about it. But anyways, if you look at this question here, they are essentially asking you for acceleration, right? If you are asked for acceleration and you know for a fact that force is given here, you're supposed to use the F equals to ma formula, right? So the method of question here is just A equals to F over m, which in this case here, what will the resistive force be? Oh, sorry. Determine the magnitude of the acceleration. The total resistive force is this much. 30 seconds. Good. Where about acceleration at 30 seconds? Okay, if you look at this question here, right, the distance time graph, here is a straight line, right? If a distance time graph gives you that here is a straight line, it means to say that the speed is constant, right? If the speed is constant, then obviously the acceleration will be 0. Very good. That's why they only give you 1 mark. There's no calculation here. Then after that, determine the forward force of the lorry due to the engine at t equals to 30. How do I do this? What do you think the answer will be? 0 here. Where got 0? Yeah. Yes, that's true. Okay, what Wing Yan says is true. If let's say this object here is accelerating at 0 meters per second square, right? Then obviously the resultant force here would have been 0 also, because this has to follow the F equals to ma formula, right? But in this question here, they're not asking for the resultant force. Instead, they are asking for the forward force instead. What's the difference between resultant force and forward force? Good, very good. There is 2 forces acting right from here. This first force is the force that is acting on the backwards direction, right? Then this forward force is the one that you're looking for. You know for a fact that the resultant force is 0, meaning to say if here was 1.4 times 10 to the power of 4 newtons, then here will be how much? Same. Very good. This is how you're supposed to do this question here. That's why it's all just 1 mark. Hey, so sad. So many people didn't come, and I brought some treats as well. This is one of the very famous cookies from Marks and Spencer, but it's infused with sugar. Okay. Anyways, next part, describe the motion of the lorry between 60 seconds to 130 seconds here. Okay. If you look at the motion between 60 seconds to 130 seconds, the one thing that you want to highlight is definitely this curving part, right? This curving part, what does it say in terms of the speed and acceleration? Good, it is not constantly accelerating. In fact, if anything, is it accelerating or decelerating? Good, very good. From here, if you look at this graph, guys, basically this graph here tells you that the gradient is decreasing, right? In a distance time graph, like I mentioned, the speed, the gradient represents the speed, right? So the speed is actually decreasing here. If the speed is actually decreasing here, it means to say what, guys? That the acceleration is decreasing. There's deceleration now, right? Not decreasing acceleration, there's deceleration here. So that's why you can write anything from here, guys. You could either mention that the speed is decreasing. You could say that it is going through deceleration. Yes, oh my god, deceleration. Right, you could also say that eventually it's going to stop, right? It's eventually going to stop. If written down any one of these 2 points is acceptable, guys. The reason why it stops is because eventually, look at this graph here, it's a flat line already. Zero distance will be covered already, indicating that obviously it has stopped. So if we written down any two of these points, actually you have to mention that it stops, right? But you can write either the speed decreases or it's going through deceleration. Yeah, can for sure.
I just write speed increases.
You only get 1 mark. It's 2 marks here. You have to mention one more thing, which is it stops up. And it stops now. Right. Okay. Question 1 done. Question 2 okay, everyone? Anyone wants to request for question 2, especially those who are online? Anyone want to request for question 2? Okay. The whole thing. 2A. This one here is quite a long calculation because they give you quite a lot of information. Usually when I'm given this amount of information, what I like to do is I like to label it in the diagram so it's more visualizing for me, right? They say that the radius is going to be 3.5 cm, but I look at the information here, this is in meters cubed, right? So I could either change this into meters or I could change this into cm cube, right? Either this into meters or this into cm cube, which obviously I'm going to change it to meters because it's much easier. So it's going to be like 1, 2, so it's 0.035 meters here. Okay, this is 0.035 meters here. I say that the depth of liquid is 12 cm, which is essentially 0.12 meters here, right? And I say that the weight of the empty jar cylinder is 2.5 newtons. This is the weight and the density of the liquid. Density of the liquid, which is obviously the water, right, is going to be 900 kg per meter cube. First question they ask, what do they want you to find? They want you to calculate the cylinder containing liquid is placed into the digital balance that displays the mass. I'm looking for mass here. Calculate the reading shown in the balance. So how do I find this mass of this whole thing here? First and foremost, I look at all the information. Number one, they already give you the weight of the empty cylinder, right? They want it in mass. How do I change weight into mass again? Divide 10 or times 10. Yeah, I was saying it's divided by 10, right? So this one here, first things first, is useful information. Divided by 10 is going to be 0.25 kg, right? So this would have been the weight of the cylinder. Right now, I want to find the mass of the water, right? If I know that I want to find the mass of the water, first and foremost, I'm going to write down the formula. Look at the information, there's density, there's volume and everything. Obviously, I'm going to use density equals to mass over volume in this case here, right? So the end position. Oh, it's kind of welcome, Kai Hong. Okay, so from here, if I'm looking for the mass, guys, then it's essentially density times volume. Mass is equals to density times volume, right? I have the density of the liquid, which is going to be 900. I don't have the volume of the cylinder. What's the formula for the volume of a cylinder? Pi r square h, very good. Pi r square would have given the area h. It's going to be pi r square h, right? Pi r square would have been the volume of the circle. H would have given you it would have given you the area of the circle, and times the h would have given you the whole thing. So it's essentially going to be pi times with your r, which is 0.035, you square it, times with your h, which was 0.12, right? So press that all into the calculator, and you would have essentially found the mass, right? 900 times pi times 0.035 squared times with 0.12. How much would that be? 0.41. 41 whatever. 42. How come the question here says 4-1?
But last year we had 0.415.
Okay lah, whatever, it doesn't matter. Okay. Anyways, press it in your calculator lah, press it properly. You have gotten 0.42, right? If you have the mass of the water already, it's just a matter of adding this with this, right? Then it's just 0.67 kg long. That's your final answer.
So instead of like using the pressure, I use like the
Pressure?
let's see, I'm sorry, for the density, right?
Mm-hmm.
I use like the mass and height.
Mass times height times gravity. Wow. Which formula is that? That one is potential energy or mgh. Mass gravity height. That's rho gh lah. Pressure equals to rho gh, dude. This formula, right, you're talking about, this is the pressure in the liquid. Yeah, you could use this, but why would you want to find the pressure? Oh, you find the pressure, then after that find back the height. Then after that, use back the pressure equals to force over area formula. Is it? Then you find the mass from here. Super long. I think it can be done. I think I'm not sure, by the way. I think it can be done, but I don't recommend doing it. Yeah, actually, if you think about it, it's the same equation. You combine these two together, is essentially going to be this equation here. You know, right? Like rho gh equals to force over area. Then bring the area over, it will be area times height. But it will be the same thing. Don't do that. Just use the normal formula. But it can be done. It can be done. But don't do it. Okay. Any other questions? Question 2B, okay, everyone? 3B2. Okay. 3B, everything. This is obviously going to be change in impulse, right? Change in momentum, right? Which is mv minus mu, right? Then after that, impulse. What's the formula for impulse again? Kayan? What? Oh, right, it is. What's the second formula for impulse? The one that relates force. Can anyone tell me what's the second formula for impulse or not? That is force related. What's the second formula for impulse? Yes, it is going to be force times time. Impulse has either two formulas, right? It's either force times time or impulse is change in momentum. Looking at this information here, this is obviously force, right? And what is this? Is this speed, guys? 6 ms. Millisecond. Excellent job, Kai Hong. This is going to be milliseconds. Means to say is 6 times 10 to the power of -3 seconds, guys. Hey, be very careful when you're doing these kind of questions. It always IGCSEs, they love to juke you guys at this. A lot of students will tell me that 6 ms is the speed. Then they're like, oh shit, should I use the mv minus mu or should I use the force times time formula instead? You know for a fact that meters per second is speed. Ms is millisecond, which is 6 times 10 to the power of -3. Okay, so from here, just times off 400 times 6 times 10 to the power of -3 here. Press that in the calculator, you'll get 2.4. Oh, yeah.
So,
Sorry, say that again.
or
M bracket minus V minus U. Yeah, it's the same thing. Yeah, it's the same thing. Hey, pass me that. Kai Hong, reward for you remembering the formula.
Oh no.
Okay. Now after that, blah blah blah. The speed, the mass of this is this thing, right? They want you to calculate the speed. Guys, let me tell you, if you're dealing with these kind of questions, and then like, how come the mass is related to the speed? First and foremost, I want you to understand that this B, It means to say this is connected, this is connected, this is connected. They're all connected. They're all connected. Right. So from here, it's just a matter of remembering the formula, right? If I'm given the mass, then I want to find the speed. How am I going to do it? I already have this already, right? Can I use the FT, use the MV minus MU formula? Then here, if this is already here already, this is going to be substituted into here. This is going to be substituted into here. You still have two unknowns, right? How do I find these two unknowns? One of it is going to be 0. Why? Yeah. If you imagine how the ball is hit up, if you ever watched badminton or tennis or any sports related to all the rackets, right? The ball, when it comes when it hits, right? This ball has to stop before it changes direction to the opposite direction, right? Meaning to say, either the final velocity is going to be 0 or the initial velocity is 0, depending on what the situation is, right? So from here, obviously you're looking for the speed, right? So I assume that the initial velocity will be 0, right? Initially, when the ball hits the racket, the speed will be 0. Then after you hit it, it's going to launch super far away with a certain speed, right? So from here, you have eliminated one more unknown. Then you can find the V already. You should get 43 meters per second. You guys get that? But you understand what I'm talking about, right? Do the formula, you will get the answer.
So we discuss 2B.
2B Part 2，刚才问你有没有讲东西，那过了你才讲。等我讲完这个先。After the energy changes, I think I don't need to explain this, right? You guys should know this. As the ball changes shape, guys, as soon as you see this word change shape, for sure it's going to be stored as elastic energy. Because once the energy releases, it will go back to its original shape, right? So from here, it's essentially going to be kinetic energy to elastic energy here, right? And as the ball leaves the racket, it's going to be elastic energy back into kinetic energy. Elastic energy back into kinetic energy here.
So for 3B Part 2, right? Is the answer 43, right?
No, it's just correct to 2 significant figures. You could write it correct to 3 significant figures, but I didn't do the calculation. That's why I'm just looking at the mark scheme.
What's EB?
What? Elastic energy. Ui, 有冇聽我講嘢嘅？ Okay, and then what do you want to do? This one, the calculation part. The pressure of gas is 400 pascals greater than the atmospheric pressure. What does this statement mean to you? Where is this 400 pascal? I give you 3 options. Is the 400 pascals here? Is the 400 pascals here, or is the 400 pascals here? Which one? Number 1, number 2, or number 3? 1. Why? Question 2B. What the hell? 这个东西叫什么？ Faster tell me what's this thing called? Very good, Ian. 再给你奖励。You deserve it. Anyway, it's called manometer. 这个 manometer is supposed to use to measure the pressure of gases. You guys, okay, let me give you a quick run through of what a manometer is supposed to be doing. Guys, pay attention here, especially for those who don't know what a manometer is. A manometer is basically used to measure gas pressure, right? For example, there could be 2 scenarios now, right? Let's say scenario number 1, where the liquid here is higher and this is lower and this higher, or the second scenario where the liquid here is higher and the liquid here is lower here, right? Usually, if let's say I have some gas trapped inside, this is pressure X and this is pressure Y. These manometers are measuring pressure difference with reference to the atmospheric pressure. First and foremost, you can see that this part here is open, right? It's because this part here is allowing for the pressure due to the atmosphere to act on it, right? So first things first, my first question is, pressure X has greater pressure than atmosphere, or the atmosphere has greater pressure than pressure X? The first one, good. Pressure X for sure has greater pressure than the atmospheric pressure, right? Because the liquid level here is lower and the liquid level here is higher. So you can imagine there are three forces acting on this whole barometer. The first force is going to be from the atmospheric pressure. The second force is the pressure due to this mercury here. It's going to be liquid mercury inside, by the way. And the final pressure is going to be pressure due to this thing here, right? Right, from here, the first things first is I know that if I were to form the equation, it's always going to be left side is equals to right side, right? So let's just say if I form the equation, pressure X will be equals to pressure of atmosphere plus the pressure of the mercury, right? Who here remembers what's the pressure of atmosphere in terms of mercury again? How many cm atmospheric pressure? Good, excellent. You deserve it. So this is supposed to be 76 cm, 76 cm worth of mercury. Let's just say in this question here, let's just say this height here is 10 cm. Then from here, I can find the pressure of X already, right? So if let's say, imagine I want to find pressure of X, I substitute all the numbers in, it will be 76 plus 10, which is going to be 86 cm worth of mercury. That's why cmHg, right? So I know for a fact that it checks out with the first equation, 86 is really greater than 76. That's why it pushes more on the left side than the right side. Understand or not? What about this one here? Everyone tell me, if let's say the height here, if let's say the height here is 5 cm, everyone find me the pressure of Y. Whatever you're talking. Hey, let's everyone do this and tell me what's the pressure here? How much?
81.
Is it 81? If it's 81, then it'll be greater than the atmospheric pressure, right? It'll be 71. It'll be 71 instead. Natalie, do you understand why? Why? Yeah, more or less lah, right? So if you don't understand, just try to draw the arrows, okay? First things first is the atmospheric pressure is acting on the right? Then here on the left, there is pressure from the gas, and then there is pressure from the liquid, right? So if I were to write an equation, it would be pressure Y plus pressure of mercury is equals to pressure of atmosphere, right? This will be 76, this will be 5, then naturally this must be 71, which makes sense because here the pressure of atmosphere for sure is greater than the pressure of Y, right? Okay, so if you can understand the concept here, it's 76 cm worth of mercury. I'll always remember your units, by the way. I'll screenshot and send this to you later on. Okay. So if you understand the whole thing, then looking at this question here, back to the question we were at hand just now. It says that the pressure of the gas is 400 pascals greater than the atmospheric pressure. So if let's say this here, number 2 is definitely pressure due to what again? Okay. How much? What is this pressure from number 2?
76.
This is pressure from the atmosphere, right? It's pressure from the atmosphere, right? And then they say that the pressure of this gas is 400 greater than atmosphere. Can I say that this is essentially pressure of atmosphere plus 400? So where should the 400 be? Where should the 400 be? Huh? There. It's here, the 400 is because of this . Makes sense or not? This is 2 is atmospheric pressure, right? 3 is 400. That's why the one on the right is atmospheric pressure plus 400, which gives you the name 400 pascals greater than the atmospheric pressure. You guys understand what I'm talking about? Seriously. So if I want to find the density, what formula do I use?
The one she said just now.
What was it?
The PGH.
Rho GH lah, then rho is not P, pressure is going to be rho GH, which in this case here, you're going to find pressure over GH is equal to rho lah. Substitute everything into the calculator and you'll get the answer. That's all I'm for. That's all I'm for. 做嗰啲啦，考試要到啊，考試要到啦，你知道冇？讀幾個月假，呢個下一個月又係考試咯。見了你那麼多年，終於沒有得見你了。Okay. All right. Yeah, just substitute everything in now. I think this one should be easy reading. Next question. I want to explain this one here. I want to highlight this question here. It's very commonly asked in IGCSEs. Who can tell me what's the improvement here? What's the suggestion to improve the accuracy here? Wood material. Oh, yeah. Okay, wood. Okay. Why? What's the explanation? Good, very good. Hey guys, this is a super standard question, guys. You must know this. In, like I mentioned before, guys, for those who are new here, listen carefully. In any heat calculated question, like for example, your Q equals to MC theta, your Q equals to MLF, Q equals to MLV, or any energy question related calculation, that is always the best case scenario. You know what's the best case scenario? It means to say, right, 100% of this electrical energy here will fully convert 100% into heat, and this 100% of the heat will only remain inside this insulating block here. This is what the calculation is assuming. But in reality, is this even possible? Definitely not, right? Why? Because we know for a fact that in reality, heat will be lost to the surrounding. So in your IGCSEs, they love to ask these kind of questions. They say that, what is the way to improve the accuracy of the calculated number? Or they'll say something like, the calculated value is much higher or lower than the real life scenario. Suggest a reason why. And anytime you want to improve the accuracy is always to minimize the heat energy loss so that the calculation makes a little more sense. Okay, so from here, the suggestion is obviously going to be any insulating material, right? It could be wood, it could be rubber, it could be glass, it could be... Of course not lah. They're asking what type of insulating material, then you write insulating material, right? So you could write any logical thing like glass, wool, wood, whatever nonsense, right? For me, I usually like to write wool, right? Explanation, reduce heat loss to the surrounding. Then, yeah. Oh, actually, sorry, let me rephrase that, guys. They're supposed to say that whatever. Reduce heat loss to the surrounding as wool is a good insulator of heat. I didn't see it was 3 marks, guys. I thought it was 2 marks. If it is only 2 marks, then you can just say that you want to reduce the heat loss, right? But if it's 3 marks, 1 mark is suggest what material is it. The second mark is to say why, and then your third mark is going to explain the reason why it's so long, right? So yeah, just make sure you write according to the marks. State how the 2 students could further improve the accuracy of the experiment by using more material. So right now, if you look, okay, these kind of questions are is sometimes in your IGCSE, I noticed this before already. These kind of questions are they're actually testing your observation skills also on, You look at this diagram here. The material is only at the side and the bottom of it. So what can I do with the material from here to help further improve the loss, decrease the loss of heat energy? What can I do? You put the material on top here. You put the material on top. This will prevent convection heat loss, right? Because heat goes upwards, if you put it on top, it's the same thing like when you cook Maggi mee, you put the lid on, right? Because you want to minimize the heat loss to the surrounding also, 有冇 cook 過 Maggi mee 咁樣嘅樣 I say, when you cook Maggi mee,
why do you need to close the lid?
For sure lah, because the heat is passing to the water, then the water will boil only when it's 100 degrees, but the water that is hot is going to release energy due to convection. So you put the lid on, so the energy is trapped into the pot, then the water will boil faster.
I just put the
你睇你啲人，你睇唔識煮嘢。Yeah, but you're supposed to put the lid on so that the energy is trapped inside and it will boil much faster. If you eat hot pot also, it's the same thing, right?
Oh, so this is why they cover the pot.
What the hell? But you're welcome. You're educated with physics, science again. Okay, so yeah, just mention that insulate the top of the block as well, right? And then the calculator value should be how much? 450. Somewhere around 450 joules per kg degree Celsius. Anyone couldn't get this? Okay, all right, very good. So looking at this question here, right? First and foremost, they asked me for specific heat capacity. What's the formula for specific capacity again, Ian? What's this? Huh? Okay. Natalie, what's the formula? Good, excellent. E or Q is equal to MC theta, right? If you want to find specific capacity, then C will be Q over M theta lah. Then, if I know that this is the formula, the next thing I look at is going to be the information. This is going to be current, this is going to be voltage, this is obviously going to be mass, and this is going to be the change in theta, and this will have been time. Can I use Q here? Definitely not. What formula should I replace for the Q? Power would have been VI, no? Good, it's supposed to be energy, which is going to be VIT, right? From here, substitute everything in. 12 times 3.8 times, do I times 10 here, by the way? Good, it's going to be 600. Divided by your mass, 2 multiplied by your 30. Power? Q is energy,大佬. P is equal to VI. Energy is equal to VIT.
And the power is energy.
Are you me and am I you? 600 from time. The change into seconds, right? Oi. What about the 30? How do I get a 30? Yeah, and press everything in the calculator. You get somewhere around 450. Yeah. Huh? 56. I don't know. The max scheme tells me 450. Yeah. But press everything in your calculator. Trust your calculator. If it's 456, then or 456. How do I find the units for these kind of things again? Okay, what? Good. What's the units? Q is what? Celsius. This one I know. This is Celsius. Joules, what's the units for this one here? What's the units for this one here? That's how you get your units. Hey guys, I've mentioned this in class many times. You do not need to memorize the units. I told you guys 1,000 times. Look at the formula and derive the units yourself, guys. You're not expected to memorize. Just like spring constant, no one remembers the units, right? But everyone remembers the formula. K is equals to F over X, right? Then spring constant must be newtons per meter, right? It's the same concept for all the calculations and all the units are. Make sure you know.
Spring constant.
Wow, what's the X? Someone tell her. Huh? Extension of the spring. Right. Hey, but it's good. At least you ask what you don't know. I like that attitude. Oh shit! What happened? Are they? Hey, are you guys still here? Is everyone still online? What happened? Ui. Projector 燒咗喂。Hey, give me a minute 啊。係咪你拉到嘅？ Yeah, it was loose. Press it again. They don't pull it up. You pull it again. Wow. For a minute there, I thought it was really, really something shocked to that. Hậu là bro, ai cũng hay rồi. What's wrong, man? Oh. And yes, sir. Wow, it's coming up already. And then so something. And then fall. It's slowly powering up, guys. Oh, I see. Okay. Huh? Yeah, don't upgrade to Windows 11, man. It was the biggest regret of my life. How? 幫我我要 downgrade 佢嘅 but I don't know how. It's that bad lah. It's very buggy and everything is not smooth at all. You know why I upgraded? Because one day, right, I was playing on my desktop. Then my girlfriend is like, "Hey, the laptop, you update. Do you want to update?" I'm like, but I was like autopilot. I didn't hear her say it all. And after she updated, why do you update my laptop? You said, Moral of the story, pay attention. GG. Anyways, yeah. Okay, moving on to the next part. Any next question? I want to highlight this question a little bit, guys. Everyone pay attention to this. I know for a fact that actually, let me see some of you guys that did this question. That would have been wrong. This one here, the optic fiber one. I told you this before. No. They're wrong. Hey, pay attention to this. This is a very, very common mistake between the students. When we are drawing the optical fiber, we know for a fact that this is total internal reflection, right? I think everyone should know this, right? Hey, friends. Come for the year 11 class, year 10 class. Anyways, hey, listen up. A lot of students know what they like to do, right? They like to do this. They like to draw total internal reflection, draw, reflect. Then eventually it will come out of the thing, right? Now, what's wrong with this diagram here is that number one, it doesn't even follow the law of reflection, right? Law of reflection states that what the incident angle must be equal to the reflected angle, right? Let's say, imagine if this is the normal, this would have been the incident angle, right? The reflected angle must be the same as your incident angle. I mean to say is like if I were to draw very properly, this would have been the reflected angle. So it would only have a maximum of 2 lines, guys. In the map scheme, it is stated very clearly. A lot of students, they like to zigzag all the way. Don't do that, guys. When you're drawing, the maximum allowable is 2 only. So if you drew something like this, then this is still acceptable. But if you draw zigzag, then it's just GG over already. 3 lines. But it's not out of the thing yet. Right, law of reflection must be the same here also. The incident angle must be equal to your reflected angle. What happened to Lian? She's not in the class, nor is she in the online class. What the hell? Who else is missing? Someone else is missing. 1, 2, 3, 4, 5.
2 lines can, right?
2 lines acceptable. Maximum.
这样不一样。老师切下面，我也去上面。
Yeah,
So in the rest, then you have to measure it out.
you don't have to measure because it's taking too much time for a 1 mark question. But you do, however, need to, at least from the eye level, here, the incident angle must be equal to the reflected angle. But it seems the same at least. If not, then
this is the eye and this is the eye.
Wow, no, don't do that, okay? Just bear in mind to draw more than 2 lines inside the diagram. Okay, very simple. Just follow. Okay.
1 line also can, right?
1 line also can. Actually, by right, it's only 1 line. Yeah, then everything else should be fine, right?
So when are you going to teach this chapter?
Which one? Oh, probably a few more months. No, 1 or 2 more months. 1 or 2 more months. Then I'm going to go to the wave chapter already.
1 or 2 more months.
Don't worry, man.
I think maybe extra 2 weeks.
You guys are in 2 weeks, right? I'm going to arrange for extra class for everyone. Everyone that's here can come, but it'll be more focused for the St. John.
So you said there was recording to teach chapter 1 more.
Oh yeah, I have it.
Did you release some?
It's on my web. It's on my YouTube channel already.
YouTube channel.
It's all the exercise booklets.
What's your YouTube name?
I'll send it to the group later. But anyways, what's the next question now? What's the next question? This one here can do our electricity one. Can huh?
Yeah, I can't. I don't know what rated means.
What?
Yeah.
Okay, then let's go through the questions together, everyone. So later send the recording. I can't fully focus during the lesson. Very good, Ian. Yeah, I wonder why you can't focus in pavilion, Ian. Okay, anyways, let's go through this question real quick lah. Okay, if you look at this question here, basically it says that each lamp is rated 60 watts, right? The word rated means to say it's going to work at 60 watts. That's why it's rated 60 watts. Okay, so it means to say this is 60 watts, this is 60 watts, this is 60 watts lah, right? And the normal working, so it has to meet 2 conditions, or they both must be 60 watts and also 110 volts lah. Yeah, you need to do
110 volts in all 3 of them.
What do you think? Hey, you were here in this class already, right? I think the parallel circuit one. I talked about the Mahathir story. How can you forget about the Mahathir story? 不知道了啦，这个是我们的 secret story 来的，等一下跟你讲啊。But anyways, you were here, right? I think you were here already. Tell me, is it possible that the other 2 won't be 110 volts? Why not? Yeah, because they're parallel, they will be equal. Means to say this will be 110, this will be 110 volts also. So from here you can find the current already, right? Current is equals to VI lah. I will be equals to P over V, which is 60 divided by 110 no? Press that in the calculator.
So the lamp are both 60 and 100.
Ah, 讲过一次 Say that again.
Oh, it's 60 watts and 110 volts.
Yes, Wing Yan, read the question properly. Some. Yeah, amperes. 0.55 amperes. Right. Now after that, they want you to find the current in the ammeter. Ma. How do I find the current in the ammeter? What times 3? Voltage added together. Yeah, you know what's going on, right? If let's say, our guys, pay attention here. If you found that one line of it is going to be 0.55 amperes, this will be 0.55 amperes, and this will be 0.55 amperes as well, right? They will combine together at this point here and flow to this ammeter here, ma. That's why it's going to be 0.55 times 3, long, because there's 3 of it, ma. Press that in the calculator. I think you'll get 1.66. 1.65. You're not trolling me, right? 1.65 lah.
The first answer cannot be 0.545,
545 can?
That's what I get.
Okay, if you wrote 0.545, then yeah, it could be 0.64. Yeah. Oh, actually, now that I look at it, right, it can only be 1.64. It cannot be 1.65. Okay, good, very good. Some luckily you highlighted this. Hey, everyone, pay attention to this. In your IGCSEs, if you see like these two questions, this question is from the previous calculation, right? What students usually like to do is they like to what's it called? Use the less significant figure, so they corrected it to 2 significant figure, right? Then after that, they bring forward the calculation to here. You cannot do that, guys. I repeat again, you cannot do this, because when there is like calculation brought forward to the next part, you must use the exact value to find the next answer. Meaning to say, if you look 600 divided by 110, it will be 0.545, right? It will be here, it will be 0.545 times 3 instead. You get what I mean? The values cannot be correct to 2 significant figures and brought forward to the next page, to the next question. It must be the exact number, then you bring forward to the next calculation here. You get what I mean? Okay. So it's supposed to be 1.64. Okay, then after that, power supply, easy, all right, it's just P equal to VI again, which is in this case. Sorry? Oh yeah, definitely 110. Don't even need calculation, this one. Okay. Then after that, calculate resistance of the filament of one of the lamp when working normally. This one is just formula all the way, right? You can use the R is equal to V over I formula, which will give you 200 ohms. Right? It's supposed to give you 200 ohms. Can. It's either 2 or 3 significant figures, ma. Right? Then after that, the last one here is supposed to be this and this. Okay? Anyone couldn't do B2, by the way. Yeah. Correct also. 3 significant figures or 2 significant figures only.
2.2.
You're supposed to use the V as 110 and your I as 0.545. Right? It doesn't matter. I repeat again, all the answers in the mark scheme is only correct to 2 significant figures. But when we do the calculation, I like to do 3. Okay, any other questions or not?
202 also correct.
Yeah, 202 or 201 is also correct. Okay. I like this question a little bit, since question 8, this one, A1. What happened here? You tell me. What will happen? Yeah, why? Yeah. So you're going to say that the positive piece of wood will move towards the negatively charged rod because the opposites attract. Right. This one, rotate. You know what's going on, right? This will be rotate, accepted, then this whole thing will rotate in this direction. Explain why, if any, is going to state and explain the thing is going to rotate in an anti-clockwise movement. Why? Because the opposites are going to attract again. It's the same answer. Or you could even say that a moment is generated or there is a turning effect or anything that's logical.
Wait, for BII, it's the second and third one, right?
Second and fourth.
7,
Second and fourth.
4.
Yes. What's the formula for resistance of a wire? Length over. Oh, yeah.
What is it to? Isn't 1/4 be like more tinier?
One box to the right, sure, possibility. Twice the resistance. Twice the resistance of each time. Half the area. Halving the area is going to increase the resistance.
But if you put it to 1/4, it's too tiny. I mean, like in a
if you put a quarter of the area, it will times 4 the resistance. Yeah, but I only want half. I want twice the resistance only one. Right. Good. It's better to ask than not. Seriously, like I'm not trolling. Oh, please. Hey, question number 9, guys. I want to explain this a little bit because it's a relatively new chapter, right? Let's go through it together, guys. If you look at this chapter, if you look at this question here, what do they want from you? It says that figure 9.1 shows a permanent bar magnet next to a circuit that contains coil and a galvanometer here. Suggest a metal from which the magnet is made of. What metal should I use again? I'll give you 2 options, either iron or steel. Why iron? Why steel? Good. Steel is a hard metal, guys. I told you guys this before, right? I'm trying to be funny, that means it's acceptable. It's acceptable. It's nickel, cobalt, or steel. But I always like to write steel because iron and steel, right? It's always just iron and steel, iron and steel.
But like
nickel is acceptable as well. Even if you wrote cobalt, is acceptable as well. But just remember the iron and steel is easiest for sure, correct one, right? But if you want, I mean, what's stopping you, right? But anyways, after that, the magnet is moved to the left and inserted a small distance of the galvanometer. Explain why there is a current in the coil. What phenomena is this when the magnet cuts through the coil? What's this name called again? What does EMF stand for?
electromagnetic field.
Induction lah. Hello, this is electromagnetic induction. EMF is not EMF lah. I told you how many times already. EMF is electromotive force, is the one that drives the circuit, drives the current in the circuit. Electromotive force is usually referring to the battery of the circuit. Remember not? So this is electromagnetic induction, right? So if you identify that this is electromagnetic induction, how do I say this kind of answers? How do I say why the galvanometer shows a deflection again?
The magnetic field of the magnet cuts through the magnetic field of the solenoid.
There is no magnetic field from the solenoid, but it definitely cuts through. Yeah, you got the right idea lah. Magnetic field from the permanent magnet cuts through the coil, inducing EMF and current in the coil. Guys, always remember EMF must come before your current. It's a very standard mark scheme answer as well. Always EMF before the current.
Wait, this EMF is EMF.
Electromotive force.
Then
Yes.
why got that electromagnetic induction?
Electromagnetic induction is the process of how current is flowing here. It's like okay, it's like saying, I still don't know how to explain this. It's like saying friction is the process that produces heat, right? Electromagnetic induction is the process that produces current.
What does electromagnet mean?
Electromagnet. Electromagnets are electricity-induced magnets. You know what's an example of electromagnet? That thing where I press the door, that's an electromagnet. You know, when the button is not clicked, right? The magnet is actually attracting the iron. That's why the door is stuck together. You know, when I press the button, it actually releases the switch here. You know, like you can imagine like there's a small little switch. There's a small little switch here. When I press the button, it releases the current and then it becomes an iron. That's why I can open again. It's not attracting anymore. This is an electromagnet. It can only be a magnet when I constantly supply electricity to it. That's why it's called the electromagnet. Electromagnetic induction is, like the name suggests, to produce electricity with the help of magnets. Remember or not? To produce electricity, which is, in other words, current, with the help of magnets. That's why it's called electromagnetic induction. Induction is to create, right? On the whole
So now if there's no electricity, let's stop us. Can we open the door?
Can, for sure.
Oh.
Because the magnet is not magnetized anymore already.
So we just cut that thing.
Yeah, I press the button, it releases a switch in the circuit, then no current will flow to the iron anymore, then it will become just iron, not a magnet. I'll arrange for experiment day for you guys one day, okay? Want to play with fire or not, you guys?
Yes.
Okay, that's my favorite experiment. So I do get on the one. We arrange one day, okay? Probably next month. Next month, I think. After the St. John's exam, we will arrange one day for full experiment day, play with all the fire and everything, all the things that you missed out from MCO. Oh shit. And everyone that's online, you're welcome to join as well. Just consider like a play day, you know. Yeah, anyways. Okay, and moving on to the next part. As the magnet moves near to the coil, NQ of the coil behaves like a magnetic pole. They say that this here starts to behave like a magnetic pole. State the polarity. What polarity will be at Q? N. Very good. Why? What law is this?
You want to repel the magnet.
Good. It's basically the Fan Gen rule all over again, right? You want to oppose the motion producing it. The Fan Gen rule. You don't know about this story also, right? tell you again next time, okay? Yeah, it's basically going to oppose the motion producing it lah. So it's definitely going to be the North Pole. Why? Because according to Lenz's law, Lenz's law states that the induced current always opposes. I think it's wrong. I think Lenz's law is spelled with a Z one, if I'm not mistaken, but let me Google that later on. Always opposes the motion producing it. I guess I should have written so big. Lenz's law states that the induced current always opposes the motion producing it. Now, guys, copy this down first. Let me explain this statement later on. Damn, a lot of days, right? More than 10 days already. Yeah, I know. I tried already. I tried already. I tried to Google how to use it. It's all gone already. Damn, a lot of days already. Yeah, GG. Okay. Yeah.
Crash is PC for 5
Crash.
Zoom screen.
Yeah. Yeah, it's not good. It's not optimized. I should have updated. Okay, let me explain this again now, guys. This statement, Lenz's law says that the induced current always opposes the motion producing. What a lot of students think, which is wrong, let me tell you what a lot of students think. They think that because this thing is moving in like this thing is moving in like this here right now, right? Then it produces the north, then it produces the current, right? That is not correct, guys. The real reality is when this thing moves in, when this magnet moves in, it actually produces the current first, then only it produces the north pole here. That's why if you look back at what I said, Lenz's law states that the induced current always opposes the motion producing it. Okay, yeah. Yeah, the induced current always opposes the motion producing it. Very important.
How do you know the current go up or down?
The right hand grip rule.
But like before the end even.
Or you must find the end first. Then only you can use the right hand grip rule. Here, actually it's going to go down lah. The current is actually going to go down. It doesn't matter one lah. They don't care one lah.
Induced current.
Always it's exactly this. Opposes the motion producing it. It's the same thing. You copy it, I don't read through it. You read through a bit now. Right. So then after that, suggest 2 ways in which the deflection of the galvanometer can be reversed. What are the 2 ways?
You put it from the other side.
Good. You could either insert the magnet from the other side here, right? Or you could switch the ends of the magnet, also possible. You should also pull it upwards. Yeah, instead of pushing it in, you pull it backwards. Any of it is acceptable. You can either switch the magnet from here to here. Of course, the north must go in here, guys, right? Then after that, it will be a different direction. You could pull the magnet, it will be a different direction as well. You could do a lot of things, anything that's logical. Okay, but for me, I'll written down something like withdraw the magnet.
How about you?
Or you could reverse
The upside down.
the polarity. No, don't try to be funny. If you turn the galvanometer upside down, it will still deflect in the clockwise direction, right?
No,
Just that.
because the wire is still like that, but just instead of like that.
No, don't try to be funny. No, it doesn't work that way. Okay, nice. Any other question? Or let's do one more question before we end the day. Wait. 6. Oh my god. Yeah. School teachers.
They run through.
Okay, wait. Let's go through this real quick. Last 3 minutes. Let's do it. Finish it. Compression obviously is going to be here, right? Because like the name suggests, the waves are compressed, right? Rarefaction for sure anywhere in between the compression, all right. The double-headed arrow, though, the double-headed arrow. You mean here? Yeah, it's acceptable. You written out any of this are acceptable. It's always going to alternate rarefaction, compression, rarefaction, compression, rarefaction, compression, right? Now after that, what about the double-headed arrow though? I give you a few options. Number one, is it here to here? Number two, is it here to here? Number three, is it here to here? Or number four, is it here all the way until it's here?
Number 2.
Good, it is number 2. Why? Because the wavelength is 0.45, right? Means say here to here is one wavelength, right? But I want 0.9, which is 2 wavelengths. So it's going to be compression to compression instead, which is going to be number 2. Okay.
For a second, I thought it was smart, you know.
What do you mean? You're correct.
I know, because I thought it's like this, and then I just take
What?
Oh,
Say that again. Say that again. That one is a different wave, by the way. That was a transverse wave, What the hell? Whoa.
Didn't run through.
Okay, so from here, yeah, what's the formula? I think I mentioned this last week already, right? Again, what's the formula for wave? Say yeah.
V equals to bridge F.
Good. V equals to F lambda. Frequency times wavelength, right? Press this into the calculator, easy, 750 times with your wavelength 0.45. Press it in the calculator, I don't know what's the answer though. 337.5. So it's 338 lah. Okay. Then after that, suggest the medium which it is traveling at. What medium is this? Natalie. Sorry? Solid. You just say solid. Let me beat you.
Shit, I was gonna say that.
Why is it? What is it? Liquid, air, or gas? I mean, liquid, solid, or gas?
Yes.
Why? Why gas? It's gas, right? For sure. Because I think I told you guys this last week also, right? It's either going to be 330 or 1,500 or 3,000, right? And it's going to be air, liquid, and solid, right? Then your reason is damn stupid also on this one here. The reason I say is because the speed of sound in air is around 330. That's your answer. Speed of sound in air is around 330. I'm stupid, but it is what it is. Yeah, that's why I give 1分。可是你不答其中一个，你就1分都没有。
Wait, you say what is the key to number?
Times 5 and times 10. Here to here times 5. Here to here is times 10. Yeah, times 5 and times 10. Roughly lah, you don't remember the exact number lah, but you need to remember times 5 times 10, times 5 times 10, times 5 times 10. If you don't remember 330, then congratulations. Okay, state one similarity between sound of frequency and ultrasound. What's the similarity?
Both are longitudinal waves.
Good, they are both longitudinal waves. State one difference.
Is it like frequency is not same?
Obviously, it's okay, you could say frequency is not same, but the more exact answer is one is audible and one is non-audible. Because ultrasound is beyond 20,000 hertz, right? Yeah, you could just say that one is audible and one is not audible. Audible Or if you don't want to use the word audible, you could just say one can be heard or one cannot be heard.
Teacher,
Mm.
donkey one cannot say they have the same frequency.
What? Do you just hear what I just said? And do you hear what you just said? What did I say here just now? They have the same frequency. Then the second statement is wrong. That means, is it? Okay. Yeah. All right, guys. That will be it for the revision month. Which one?
The one towards B.
Critical angle. What's the formula? Good. 1 over sine C equals to n. Then 2 use of optical fiber.
Equals to what? What's N?
哇，你真的不會咯，唔係講笑啊你。喂 ，this is refractive index 喂。
teacher we did this.
No, we did, but then like.
For the time constraint purpose, I will explain this next week again. 2 uses of optical fiber is definitely going to be optic fiber cables, right, for telecommunication and endoscope. Endoscopes and telecommunication. Telecommunication. It's basically what Unify is running on optic fiber. Okay.